This is the second video dealing with modeling with sinusoidal functions, dealing with phase shift. But before we move on to the next question, I want to take a look at the answer so that you guys know certain parts of this formula. Okay, so right now, this right here, that number represents our A value. Now the absolute value of that was our amplitude. Okay, over here, this is the D value. That's our midline right there. So we know our midline was right there. The last video talked about how to get it. But I want you guys to understand, it's kind of cool. It says, assume the length of the year, the period was exactly 365 days. Well, look what ended up being our denominator, 365. And then it also said, note that June 21st is 171 days after January 1st. And look how that was, how we end up writing that. So you can kind of see how this right here was shifted 171 units, and that deals with our phase shift, dealing with it. Okay. Real quick, I think I'm going to go ahead and type this in, and hopefully you guys will see how it works. And I want to make sure you know how to type things into the graphing calculator of Desmos. I'll go ahead and put the little division bar. Type in 2, I can type in pi, parentheses, I'm going to put x minus 171, 365, plus 739.5. Now, one thing you're going to have to do is, for the graph settings, you're going to make sure that you got to be in radians, not degrees. Got to make sure you're in radians. Another thing, we want to kind of create a window that we want to be able to see. So I'm actually going to set the x-axis from 0 to 365. All right, 365 days in a year. And the y-axis, we're going to go down. We talked about the minimum and the maximum. So if we go back to the problem, you kind of see where the minimum and maximum. There's the minimum. There's the maximum. So I'm going to set, so go from, say, 300 to 1100 is what I'll do. I'll go from 300 to 1100. All right. And that allows us to be able to take a look at the graph. All right. So right now you can kind of see the graph. You can see the maximum, 171 days after January 1st. Now January 1st is dealing right here on the y-axis. So basically that was the temperature, sorry, not the temperature, that was the minutes right there dealing in January. Then it got up to the maximum sunlight, and then over here it gets back down to its lowest right here at 382.5. So January, that's where it was in January. This is where it is at its minimum, and this is where it is at its maximum. All right, so when you're doing the graph, make sure you go to the graph settings, and you can kind of adjust the x-axis and the y-axis so that you can see your function. Obviously, if you just want to zoom out far enough, you can zoom out far enough. And when you're doing this, it's also helpful to write in the midline. So you can kind of identify different places where the midline is, where the maximum is, where the minimum is. Okay? So you can also do that as well. Now, let's go ahead and move on to our next question. All right. Let's take a look at this. It says a pendulum is swinging next to a wall. The distance from the bob of the pendulum to the wall varies in a periodic way that can be modeled by a trigonometric function. The modeling function has a period. Oh, cool. It's got a period of 0.8 seconds. It's got an amplitude of 6 centimeters, and its midline is 15 centimeters. At time t equals 0.2, the bob is at its midline, moving towards the wall. Find the formula of the trigonometric function that models the distance h between the bob and the wall after t seconds. Define the function using radians. Here we have h of t. And it also says, what is the distance from the pendulum to the wall after 0.5 seconds? Round your answer, if necessary, to 2 decimal places. All right, so kind of get your journal out if you want to. We're going to go ahead and work through this from beginning to end. Right now, I want you to imagine a pendulum. All right, so here's a pendulum. And this is the bob. It just kind of goes back and forth, back and forth. So when we're doing this, we're going to imagine. All right, I want you to imagine there being, say, a wall say the wall is right there. Let's call that the wall. All right, and this right here, the bob, it's either getting closer to the wall or further away from the wall. All right. So when you're imagining this, is kind of what I want you to imagine. We'll call this the minimum distance from the wall. We'll call this the maximum distance from the wall, and we'll call this distance the midline of the wall. All right. So what we're going to do is I'm going to create a little graph right here to go along with it. Hopefully this will be helpful. We'll kind of go back and forth, and we'll call this the midline. All right, and we're going to make some points right here, some important points. Now let's go back and take a look at the question. It says right here, hold on, let me go back. All right, so here we go. It says that the bob is actually moving towards the wall, even though it's at the midline at point 215. All right, so it's going towards the wall. If it's going towards the wall, it means it's going towards its minimum, not its maximum. And then eventually it'll get towards its maximum and come back to the midline. So this point right here is at point 2, comma, 15. All right, and we're going to break this down into its other points. Now, when looking at this graph, it looks like a negative sign graph. So I'm going to put y equals negative sign of x. All right, so a negative sign graph, you'll notice it goes away from the midline, going down versus going up. That's what a positive sign graph looks like. So we're going to identify different things. We're going to identify the a value, b value, c value, and the d value. Now the d value is easy. We already know it's 15 centimeters. We'll put 15 cm. All right, and they did give us the amplitude. The amplitude they said was 6. All right, so our amplitude 6, but this is a negative a value because we're going down. My a value is going to be negative 6. It gives us our period. It says our period is 0.8 seconds. So right now I'm just going to write the period. Equals 0.8 or 0.8 of a second. All right, and let's see here. That's all we have. All right, so we're going to take all this information and we are going to build our function, which our final answer will be in h of t. And I'm going to do it on this page so you can kind of imagine it going back and forth. All right, so let's separate our negative sign graph into 4 parts. So right now I'm going to break this down into each of its sections. So here we have a quarter, and another quarter, and another quarter, and lastly our last quarter. Alright, so if we have a period of 0.8 seconds, that means each of these little sections, you could take that period and divide it by 4, and 0.8 divided by 4 is 0.2, alright, 2/10. So right here, this is going to be at 0.4, comma, whatever the distance is, basically the minimum. So if our amplitude is 6, all right, and we start at 15, that's going to put us right here at a 9. If you take away 6 from 15, you're at a 9. Over here, we're back at the midline, and that ordered pair will be 0.6, comma, 15. This ordered pair is going to be at 0.8, comma. Now we're going to add 6 to this. We add 6 to this, we get 21. So we have 21 centimeters away. All right, so we're going to write certain things down on this little picture. So the minimum, it looks like the closest it gets to the wall is 9 centimeters. The midline is going to be at 15 centimeters, and the maximum distance away from the wall is going to be 21 centimeters as it goes back and forth. And then finally, at 1 second, it's back to the midline at 15 centimeters. All right. So what we're going to be looking for when we eventually type this into Desmos, we're going to make sure all of these points line up. Now there is a phase shift, all right, and that phase shift is going to be pretty important because this graph did not start at 0, 0. It started at 0.2, comma 15. So we have a phase shift of 2/10. That's our phase shift. So what do we do with all this information? We have the phase shift, which is 0.2. We also have a period of 0.8. We have an amplitude of 6. We got that. We have a midline of 15. So how do we put this all together? How do we find our B and our C? Now, I'm going to show you probably a more complicated way, and then I'll kind of show you how I'm going to build it at the end. All right? So just remember, whenever you have a period, 2 pi divided by B is equal to our period. So if I have 2 pi divided by B as our period, and our period is 0.8, that's the same as saying the fraction of 4/5. So when I cross multiply, 0.8 is 8/10, that's the fraction equivalent is 4/5. When I cross multiply, I get 4 times B equals 10 pi. All right? And when I divide both sides by 4, I get B equals 5/2 pi. Now I have my B value. So my B value right here is going to be 5/2 pi. Now once I find my B value, I can find my C value. Just remember, the phase shift is equal to C divided by B. So if C over B is equal to 2/10, 2/10 reduces to 1/5. So now I'm going to set 1/5 equal to the C value over my B value. Well, since I just found my B value, which is 5/2 pi, I'm going to write it as 5/2 pi. 5/2 pi. And then I'm going to cross multiply once again. All right. So when I cross multiply, I get 5C equals 5/2 pi. And then I'm going to multiply both sides by 1/5. Now you could divide both sides by 5, but multiplying both sides by 1/5 is the exact same thing. And C equals, all right, these 5s are going to cancel out, and we're going to be left with pi/2. All right, so my C value, just found my B value, it's 5/2 pi, and my C value is just pi/2. All right, and I'm just going to put right here, we're going to put pi/2. All right, so I'm going to write our final equation right over here. All right, so I'm going to say h of t equals -6 sine, open parentheses, then I'm going to put 5 pi/2, put the letter t right there, minus pi/2, close parentheses, plus 15. And that is my equation. Now I'm going to show you a little bit simpler way of writing this. See if you guys can understand how I do this. All right. So over here, this is what I'm going to use. I'm going to type into the Khan Academy, and then I'm going to type both these into Desmos so you can see that they are the exact same thing. All right. So I'm going to write -6 sine. So far everything is the same. Now watch what I do here. Now normally, all right, normally a period is 2 pi, but right now our period was not 2 pi. Our period was 0.8. So watch how I'm going to write this. I'm going to put 2 pi up here in the numerator, and the denominator I'm going to put 0.8. And then in this set of parentheses, I'm going to put our phase shift. So our phase shift, I'm going to put t minus 0.2. T minus 0.2 right there. I'm going to close it, and then I'm going to add a 15 because that's our midline. So I want you to take a nice long look at what I'm going to type in the Khan Academy and see if you can see what I just did. Here's the important things. Here's the phase shift. There's that 0.2 phase shift. Okay? Here's the period right here. The period is 0.8. So if you're looking at this section deals with the phase shift. This part right here deals with the period. So our period was 0.8. Now before, if you look back at a previous problem, go back here, you'll notice right here, there's the phase shift of our old one, t minus 171. Our phase shift was 171. There was a period 365. There's the amplitude. There's our midline. So I'm using the same process with this one. It's just different numbers. So there's the 2 pi. There's our phase shift. There's our period. Now we're going to type both these into Desmos so you can see that they are indeed the exact same thing. So let me clear this out. All right. We're going to go ahead and type these into Desmos. All right. So I'm going to put h of x, I know we're going to use t for the Khan Academy, equals -6 sine, open parentheses, the division, 2 pi, open parentheses, x minus, that's my corgi scout. She's on the lookout. She's on the prowl. 0.8 plus 15. Alright, I'm going to hit home. Alright, make sure we are in radians, not degrees. Alright, zoom out a little bit. There we go. Wow, that's pretty. That period's really short. Alright, goes back and forth. Now we're going to go ahead and do, I'm just going to do f of x instead of h of x for the other one. Equals. And we said the other one was -6 sine. Let me take a look real quick. 5 over 2. There we go. 5 divided by 2 pi x minus pi over 2 plus 15. On the outside. My bad. There we go. Plus 15. Alright, and now I'm going to change the color so you can kind of see it a little bit better versus just black. Alright, done. Now we're going to restrict our window so it's not, it's a lot going on there. So let's go and restrict our window. Let's go and start the x-axis from 0. And it said it finished at 0.8, so I'm just going to do it at 1. Alright, do it at 1. And that should give us a nice view of the graph. Alright, so basically it started right there. Alright, now it said, remember, the midline. Y equals 15. There's the midline. I'll change the colors on that. This should allow us to see a lot of important points. Alright, so there we go. This is what happened. They gave us the midline right there. Alright, so this is where we started, right there, the midline. Okay. Then it got closer to the wall, right there. That was the minimum. Then it went back to the midline. It went up to its maximum, which is 21 centimeters away from the wall. And then finally, it finished right there at 115. So if you take a look at all of these points right here, alright, take a look at these points. Alright, there's my corgi scout. Let's go back to our original drawing, and there's our points. 0.2, 15, goes all the way down, back up, and it finishes. By doing this, it allows you to be able to see if you got the correct concept or not. So now that I have everything, I'm going to go to the Khan Academy, and I'm going to type everything in nice and neat. But before we do that, it also asked us to figure out the distance from the pendulum to the wall after just half of a second and round our answer to 2 decimal places. So this is where Desmos comes in handy. Go over here, alright, and right here what I'd like you to do is just type in half of a second. And there's our answer. It says 10.757. So I'm going to call that 10.76 centimeters. All right, because I'm going to round that. That's a 5 or higher. It rounds up to 10.76 centimeters. All right, so right here, what I'm going to type in right here is -6 sine, open parentheses, 2 pi, open parentheses, t minus 0.2 all over 0.8, close parentheses, plus 15. And what is the distance from the pendulum to the wall after half of a second? After half a second, put 10.76. And that's what I'm going to write in. All right, let's go ahead and do that. All right. -6 sine, open parentheses. I think I forgot to put a t. Oh, no, there's the t. There it is. Put the division bar. Up here, I'm going to type in 2 pi, open parentheses, t minus 0.2. There's our phase shift. Our period was 0.8. We had a midline of 15. All right. And then we're going to type in 10.76. Cross our fingers and our toes. Make sure we typed in everything exactly as it appears. All right. Looks pretty good. Let's go ahead and hit check. And voila, we got it right. All right, so we have one more problem to do. If that's enough for you to go ahead, just go ahead and keep moving forward. You don't have to watch the rest of the video. But if you'd like one more example, we're going to do one more example. All right, and it looks like this one's going to be pretty easy. It's just asking us for what is the midline of this function. So all I have to do is basically interpret the midline. All right, so let's just take a look at this and interpret the midline. And we're actually going to interpret everything. All right. Right here, I'm going to write down what our amplitude is, what our A value is, what our B value is. Actually, not what our B value is, but we're going to talk about the period. Like, what would, if just by looking at this, figure out the period, figure out the phase shift. And last thing we're going to figure out is the midline, which happens to be our D value. Okay, our amplitude, all right, is 2 over 1,000. We can just reduce that. All right, so our A value is 1 over 500, and that's our amplitude is going to be the absolute value of that, which is still 1 over 500. So that's our amplitude. That's a horrible looking M, but all right, there's our amplitude, which is 1 over 500. It looks like our period, all right, if I say 2 pi over 4, all right, so our period is simply going to be 4 units. That's our period, all right. Our phase shift, it looks like it's if it says plus 0.2, our phase shift is going to be minus 0.2, all right. And if you're trying to figure that out, it's just like, what number would you plug in there to make this part right here equal to 0? All right, and I don't see things being added or subtracted from that, so I'm going to say our midline is going to be at 0. But if you're ever second guessing yourself, just type it in. Just type it into Desmos, and I'll go ahead and do that right. We'll do it right now, and we'll take a look at where our midline would be. All right, close that out. 2 divided by 1,000. Right. Sine, open parentheses, fraction 2 pi x plus 0.2. Alright, and let me look real quick. Over 4. Now we're going to have to zoom in quite a ways to be able to see anything. Alright? So we're going to go ahead and go to the gear right here. Right now I'm going to go from 0 to 4, because I think that's our period. Alright, 4, hey, look at there, 0 to 4, that works really well. Alright, and you can kind of see we had a phase shift here. Alright, but if I put y equals 0, alright, you'll see it starts at negative 0.2. It goes up right there to 0.8, 1.80, and right there, there's you can clearly see our midline is right there at 0, and it finally finishes right there. I'll zoom out just a bit so you can see it a little bit easier. There's where it starts, there's its maximum, there's its midline, there's its minimum, back to the midline. So when you guys are looking at this graph, I want you to kind of see it this way. It goes up and down and back up. So its midline is right there at 0. So it makes it very easy when you're doing the Khan Academy, like, hey, there's nothing being added to or subtracted to at the very end. So what is the midline? Just y equals 0, and you're done. Alright? Hope you guys are having a great Monday. Hope this is helpful, and if you have any questions, you can send me a text on Remind, and I'll do my best. You can take a screenshot of yours, and I can help you with it, give you some hints. Alright? Have a good day.